So today what we're doing is we're looking at solving compound inequalities. Well, in order to do this, you got to know, one, what an inequality is, and two, what a compound inequality is. You should already know what inequalities are, so let's talk about compound inequalities. Compound inequality is a sentence with two inequality statements joined either by the word or, and. Okay, so you have these inequality statements, and they're joined by or, and they kind of look kind of like these right here. And what they're doing here is they're saying, well, x is greater than or equal to 3, and x is less than 7. So we go from our inequalities, and they're joined by an and statement here. And it can be written kind of like this. 3 is less than or equal to x is less than 7. And what it's actually stating here is that, hey, this x right here is between 3 and 7, not including the 7 because there's no line under this one. So it's in between here is what's going on. And they can take this and they can say, well, we can put it on a graph to make it where we understand what's actually going on. So they take and they place it on this graph and they actually graph it. Well, let's actually graph this. Okay, so the first one right here, this one, is at the 3, and it includes it, so I close in the dot. Okay, and it says x is greater than or equal to 3. So greater than or equal to 3. So everything on here. Okay, and then they come back over here and they say and, so it has to have this other one also. X is less than 7. So open circle, not a closed, less than. So both of these statements have to be true in order for this to work. So it includes everything in between here and here, the 3 here. So we have our actual number line here that I put on here, but I just wanted you to see how we actually graphed it and how we got to this point right here. So you have the 3 going that way. Well, everything from 3 up to 7 works. And then everything from the less than the 7 to the 3 works to make this a true statement and to make it work for our problem here. So when you're looking at this, that's what you're looking at. Now that's the and statements, right? Both have to work. And it includes everything in between there, and that's how you kind of graph that. Our or statement, just one of the two has to work. So x is less than 3, or x is greater than 7. Now this is just one way that you'll see these. You'll see them another way, but let's graph it. X is less than 3. Well, come down here to 3. It's less than 3. X is greater than 7. X is greater than 7. And oftentimes this is what you're looking at when you're looking at an or statement, where the and statement, they both have to work in order for it to be a true. Just one of these has to work in order for it to be true. Okay? That's what you're looking at when you're looking at compound inequalities. Or statements, one of the two has to work. And statement, they both have to work to make it true. Okay? Well, let's take a look. And statements. And statements are intersections where the graph of two inequalities overlap. It's where the two graphs overlapped, and I just showed you that here just a second ago. Well, a lot of times you're going to see them written like this, and you're going to have to take and put it on the graph to say, okay, between here and here, that's when this is true. Right? So in order to do that, you look at this problem, you go, well, how do you know when you have this what to do with it? Well, you take this and you split it apart into two problems so that you can actually work it out and figure out, well, what is the x here? So we're going to take and we're going to rewrite this. -2 less than or equal to x minus 3. So now I have one problem here, but I'm going to do it again and I'm going to put it over here. X minus 3 less than 4. And I'm going to solve these inequalities all the way down, and then I'm going to put it on a graph to say, well, between this and this, that's when it's a true statement. Okay? So we're going to add 3 to both sides. So gets us 1 is less than or equal to x. So now I have one inequality here, and what I would do is I would actually flip this to make it easier to graph. X is greater than or equal to 1, makes it easy to graph. And then I'm going to come through here and I'm going to solve this one. Add 3 to both sides, x is less than 7. And now I'm going to place it on a line graph here. Put 1 there, put 7 there. Okay? X is greater than or equal to 1. So close circle, okay? Close circle, and it goes that way because it's greater than. Okay? And then come over here, x is less than 7, so open circle, and it's going this way. Well, where do they overlap? That's what we're looking at. Well, we overlap all in here. So right in here is what we have. Okay? So if we wanted to write this, it would look like this. 1 less than or equal to x less than 7. So we could rewrite it like this. And all this is stating is everything between 1 and less than 7 is what x can actually be. So we could write it like this, or we can graph it out like this so that we know that. Now it ends right here, and it comes all the way in between here. Now it doesn't include the 7, but it does include the 1. It's where it overlaps, right? The intersection, where the graph of two inequalities overlap. That's our AND statement, okay? That's the AND. So let's take a look at an OR statement. OR statement. OR statement is a union. It's true when at least one of the inequalities is true. Okay? And we're going to talk about this all of both here in just a second. But the union is true when at least one of the inequalities is true. So at least one of these has to be true. And guys, you're going to see it written like this. You're not going to see it written like this right here. Okay? Your OR statements will be written like this. All right? So, again, all you have to do is take them and solve them. A plus 1 less than 4. Well, add the inverse to both sides. A is less than 3. Or, and we're going to add 1 to both sides. A is greater than or equal to 4. Now, all that has to happen is that one of these two has to be true in order for this to work. Okay? But we're still going to put it on our graph. So we have 3 here, we have 4 here, and A is less than 3. So 3, no line under it, so open circle, less than, goes this direction. Okay? A is greater than or equal to 4, so it includes 4, closed circle, to the right, and that's what it's going to look like on your graph. Now, either one of these has to be true in order for this to work. So A is less than 3, or A is greater than or equal to 4. One of these two makes this true. Nothing in between here will work. That's what that's saying. A cannot be anything in between here, and it can't be 3. That's what's going on here. That's your OR statement. Now, all of both. Either one of these has to be true, and that makes both of them true. That's what the all of both means. Okay? It's all of both of these. As long as it fits one of the two, it works for both, and we're going to take both of them. Okay? That's what we're looking at. All right, so I got a couple of different problems up here, kind of to get us seeing it. We're just going to work through them, talk about them a little bit as we go. So, y minus 3 is greater than or equal to negative 11, and, that's our and statement. So both of these have to work. It's where they intersect, it's where they overlap. Okay? Y minus 3 is less than or equal to negative 8. So our graph should cross over each other. It's where they both are going to cross over. So we got to solve. y minus 3 is greater than or equal to negative 11. Add 3 to both sides. Y is greater than or equal to negative 8. Okay. Add 3 to both sides. Y is less than or equal to negative 5. Now, I'm just going to put them on the graph. They both have to work. Okay. So we got negative 8 over here, got negative 5 over here. Y is greater than or equal to, closed circle, negative 8. Goes that way. Y is less than or equal to negative 5. Again, closed circle, goes this way. Okay, where do they overlap? Well, everything in between here. That's what it's saying. All of this right in here. So y can be any number in between negative 8 and negative 5, and it includes both negative 8 and negative 5. So anything in here works for y, and that's what you can have. Right? So if I wanted to rewrite this, see if I can do this correctly. Negative 8 y negative 5. Yeah, that'll work. Okay, so negative 8 is less than or equal to y is less than or equal to negative 5. Make sure I wrote that right. Yeah, because the y is greater than 8. Yeah. Okay. Oftentimes rewriting this, be careful. Okay, you make mistakes easy there. But do all of these numbers fit in here? Everything in between here fits there, and that works. Okay, watch that. This is what you should be looking at. And now if I want an example of one of the numbers that went in between here, negative 6, does that make it a true statement? Yeah, absolutely. Okay, and you're going to see that too. You're going to have to do that. All right. All right, number 4 here. This one's a little bit tricky at the end. Okay, so it's an or statement. So as long as one of them works, we're taking them both. All right, it's all of both of them. Is that right? Yeah, all of both. All right. So we solve them, and this is the way it's going to be written. You're going to see it just like this. Okay. So move the 7 over to negative 2m. 220, divide by negative 2. Oh, oops, sorry. Forgot to take my negative 7 over there. So 6. Yeah, make sure you do that correctly. Yeah, 6. Now divide by negative 2. Divide by negative 2. But remember, when you divide by negative 2, you flip that inequality. Watch that. That's a common mistake. So watch that. M is greater than or equal to negative 3. Watch that inequality. You may have to do that. Okay? Same thing over here. Divide by 5, divide by 5, m greater than 5. Now I didn't flip it over here because it wasn't a negative number that I divided by. Okay, so I have it fine there. Now I'm going to put this on our number line, and this is an or statement. Remember, so as long as one of them works, they both work. Now, negative 3, 5, it includes the negative 3, so closed circle, okay? And m is greater than or equal to negative 3, so everything greater than or equal to negative 3, so all of this, okay? Or m is greater than 5, open circle, and to the right. Now look, it includes both of those. Now, it intersects right here, but in our or statements, we're not looking for it to intersect. We just need it to be a true statement. In this particular one, this is going to be our answer because it includes this when we go through there. So we're going to be doing from here over because this is the one that matters. Because as long as it's true for either one of these, it's true for both, all of both. So here we include this one. So this right here, this line is going to be the one that we're looking at. But what if this was an and statement? Instead of an or statement, if it was an and statement, well, we need to see where they would intersect and where they overlap. That would include this part. So if it was an and statement, it would be this answer that we're looking at. Whereas here it's an or statement, so we like this one, okay? Because as long as either of them work, we're good. When we're dealing with an and statement, both have to work. So we would be looking at this one. So pay attention, watch this, you're gonna see this, okay? This one is, this is the one that will get you, okay? Be careful with that. It's not terribly complicated as long as you know how to solve inequalities. The inequality part, just solving down to find out what the variable is. Once you have that and you know how to graph an inequality, this becomes much easier. If you have questions or you need any help, let me know.